Hi guys, I hope you are all doing well. Let's see today's question. So today's question we are taking this up from the topic of definite integration. And if I talk about the question that is given to us here from this topic, the question tells us to find the value of an integral which has the limits from -1 to 2, and the function that is given to us is log base e x plus square root of x square plus 1 dx. And in the question, we have been asked what is the value of this expression. And I have been given four answer choices here. They are root 5 minus root 2 plus log base e, 7 plus 4 root 5 over 1 plus root 2. The second answer choice I have been given here is root 2 minus root 5 plus log base e, and the same thing, so 7 plus 4 root 5 over 1 plus root 2. Third answer choice I have been given here, it is root 5 minus root 2 plus log base e, 9 plus 4 root 5 over 1 plus root 2. And the last answer choice I have been given here is root 2 minus root 5 plus log base e, 9 plus 4 root 5 over 1 plus root 2. So we need to figure out which one of the answer choices that are given to us is the correct answer for this question. Let's try to solve this question further. Let's try to figure out which one is the correct answer choice here. So if I have to evaluate the value of this integral, which goes from the limits -1 to 2, and it's basically log to the base e, and the expression given to us is x plus root of x square plus 1 dx. Now I have to find log to the base e's integral. So this is the only one function I have. So to make it in the form of a product of two functions, I can manipulate this as one function multiplied with the other, that is 1. So I have to basically find the integral of product of these two functions. To find the integral of product of two functions, let's say u times v, I can just use the idea of product of two functions rule, which is u integral v dx minus big integral derivative of u integral of v. And whatever we get, we take integral of that with respect to dv. Now that's the whole idea we have to figure out. But for that, we need to also see which one of the two functions is u and which is v. So that we can decide according to the rule which we have is I late. So I basically stands for inverse trigonometric functions, L for logarithmic, A for algebraic, T for trigonometric, and E for exponents. So exponential functions comes at the end. Now we go from left to right. The one which comes first becomes u, and the other one which comes is v. So here if I see 1 is basically x raised to 0. So it's an algebraic function. So 1 comes here. And log of this entire function is a logarithmic function. So this entire function is coming first. So this part becomes my u thing, and this becomes my v. So I have to just use the idea now and find the integral of this product of the two functions. So I can write this as -1 times -1 to 2 as the limit. The two functions are 1, and the other is log base e x plus root of x squared plus 1 dx. So this entire thing is my u and this is my v. So I can write this as u. So u as it is integral of v. So integral of -1 to 2 1 dx minus big integral derivative of u. So we are finding derivative of this entire thing times integral of v again. So that is 1 dx. The whole whatever answer we get, we integrate the whole thing with respect to dx. Now let's try to solve this question. So log base e x plus root of x square plus 1, and integral of 1 is nothing but just x. So we have these two functions. The limits go from -1 to 2 minus integral of -1 to 2, derivative of this entire thing. So derivative of a logarithmic function is 1 over that function. So 1 over x plus square root of x square plus 1 times derivative of x plus root of x square plus 1 will become 1 plus root of x square plus 1. So we know root of x is 1 over 2 root x. So it becomes 1 over 2 root of x square plus 1 times derivative of x square plus 1, which is 2x. So this and this cancels. We have this. And further integral also, if I figure out integral of 1 is just x. So we have to find the integral of entire this function with respect to dx. Let's keep this first part as it is. So I have x log base e x plus root of x square plus 1. The limits go from -1 to 2. So first part I've written as it is, just I've taken this x written ahead and then this logarithmic function, and minus integral from the limits -1 to 2. This I can write as 1 over x plus root of x square plus 1 times. Now here, if I see, I have the denominator root of x square plus 1 for the second part of this expression, but for the first part, I don't have that. So I'll make it root of x square plus 1 common from both by multiplying by numerator and denominator with root of x square plus 1. So I have the same denominator now, root of x square plus 1. So I have root of x square plus 1. And the numerator becomes 1 times root of x square plus 1. So sorry, root of x square plus 1. Plus here only 1 times x. So plus x. And that is again multiplied with integral of 1, which we figured out. So x. And then integrating it with respect to dx. Now, if I see here, I have this same terms in the numerator and denominator, so that gets cancelled. I'm just left with x log base e x plus root of x square plus 1. The limits go from -1 to 2 minus big integral -1 to 2. This whole term got cancelled, so I'm just left with x over root of x square plus 1 dx. Now, this x square plus 1, which is there in the root, I can just put it as another variable. So x square plus 1 is just, let's say, t. So 2x dx is dt. So x dx is dt over 2. So I get from here x log base e x plus root of x square plus 1. The limits go from -1 to 2. If you want, you can just plug in the values of x as -1 and 2 here. But I'm waiting and not putting it until I get my second part also figured out in the form of expression. So I can then apply the limit totally to the entire expression that I get. So if I see this, now I get this in the form of integral, and because -1 to 2 were the limits for x, since I'm substituting x square plus 1 as t, this values of t will become something else apart from -1 to 2. So the value of the limits would change, goes from -1 to 2. So if I put it here, -1 squared is 1, 1 plus 1 t becomes 2. And if I put 2, 2 squared plus 1, which is 5. So t goes from 2 to 5. X dx is dt over 2 divided by square root of t. So I have integral of t raised to half, which goes up and becomes t raised to minus half. So x log base e x plus root of x square plus 1. The limits go from -1 to 2 minus. This becomes half. Limits go from 2 to 5. And I get dt over root t. Root t is t raised to half. So when it comes up, becomes t raised to minus half. So it minus half, it has minus half, and t raised to minus half, if I take the integral of that, gives me t raised to half over half. Limits go from 2 to 5. And here I have this limits from minus 1 to 2. If I apply the limits here, the upper limit, if I put it inside, and the value of x would become 2 log base e, 2 plus root of 2 square plus 1, so root 5, minus, if I put minus 1 log base e, minus 1 plus root of x square plus 1, so 1 minus 1 square is 1, 1 plus 1 is 2. So we get this. And this also, I get this minus half. This 1 over 2 in the denominator, if it comes up, becomes 2 over 1, and t raised to half is nothing but root t. These limits go from 2 to 5. So let's apply the limit in the second part of the expression also. And if I try to solve this and simplify this, I get 2 log base e, 2 plus root 5, minus minus plus, so plus 1 log base e, root 2 minus 1. This becomes minus, so root t, so root 5 minus root 2. So I get this minus root of 5 minus root 2 if I see here. If I open this minus sign with this bracket, I get this signs change, so it becomes minus root 5 and plus root 2. So this basically becomes root 2 minus root 5. Once I get that root 2 minus root 5 plus this entire thing, if I see, I have this as plus 2 log of base e 2 plus root 5 plus log of base e root 2 minus 1. So I get from here root 2 minus root 5 plus log of base e 2 plus root 5 squared. Using the property of logarithms, I can just write a log b as log b to the power a. And here I get log of e root 2 minus 1. Once I have this with me, what I can do further is I can just make it root 2 minus root 5 plus I can apply the idea of log a plus log b, which will basically become log of a times b. So I get 2 plus root 5 squared times root 2 minus 1. Now once I have root 2 minus 1 here, I will just use the idea of rationalization here, because if you see in the question, the answer choices have root 2 plus 1 in the denominator. So to have the root 2 plus 1 in the denominator, I should be rationalizing this expression. So to rationalize this expression, I would be multiplying this inside only with root 2 plus 1. Because that should be there in the denominator according to the answer choices. So this would make it a minus b times a plus b, which is a squared minus b squared. So this becomes root 2 minus root 5 plus log base e, 2 plus root 5 the whole square. So 2 plus root 5 the whole square means a plus b the whole square. So a square plus 2ab plus b square. And this becomes a square, so root 2 square, which is 2, minus b square, which is 1 square, which is 1. So 2 minus 1 and divided by root 2 plus 1. So if I see here, I get root 2 minus root 5 plus log base e, 4 plus 5, which is 9, plus this becomes 4 root 5. 2 minus 1, so multiplied with 1, divided by root 2 plus 1. So from here I get root 2 minus root 5 plus log base e, 9 plus 4 root 5 divided by root 2 plus 1. So this is my entire answer for this question. So root 2 minus root 5 Root 2 minus root 5 is not present in this 2, so these two answer choices are out. Now, I have this in both of them, log base e 1 plus root 2 also in both of them. I have gotten 9 plus 4 root 5. So if you see the answer, I have 9 plus 4 root 5 and not 7 plus 4 root 5. So this is a correct answer choice because here it is written 7 plus something. So B is also out. So D becomes the correct answer choice for this question that is given to us here. I hope you have understood how to solve this type of question. So I just used the idea of manipulation and converted the entire given question into product rule. Once I got the question converted into two functions, I just applied the product rule here. And applying the product rule gave me the answer for the question, and that answer basically matches with the answer choice D. So D becomes the correct answer for this question that is given to us here. I hope you have understood how to solve this type of questions, which deals with the ideas of finding the integrals of the function with the limits given. It can be anything from A to B. So here in this question, the answer choice that is correct is option D. I'll see you again tomorrow with some other question from some other topic. And we are going to continue our series of questions on JEE mains. So stay tuned for more videos to roll out. Also, if you're enjoying these videos that we are doing on everyday basis, please do like the videos as well and do subscribe to my channel and share this channel with your friends also who are involved in the preparation of questions on JEE so they can also take the benefit from these questions that we are solving. Thank you.